Hello, in this lecture we will find the area of triangle ABC in two different ways. In the drawing we have triangle ABC, side AB of triangle ABC equals to 8 units, side AC of triangle ABC equals to 14 units, and we also know that angle ABC of triangle ABC equals to 2x, and angle ACB of triangle ABC equals to x degrees in size. And we want to find out the area of this triangle, triangle ABC. So I will start with the first method, and first of all I will draw line segment from point A, line segment AD, in such a way that angle ADB will be equal to 2x. Okay, so from point A I will draw line segment AD. So the touching point between the line segment and side BC of the triangle is point D, and angle ADB equals to 2x. So I draw line segment AD in such way that angle ADB equals to 2x. Okay, so actually in triangle ABD we have two equal angles. Those two angles are equal to each other. Both of them are equal to 2x, and we actually have a rule. I will call it rule number 1. Rule number 1 states that in front of equal angles in the triangle there are equal sides. So I will write down the rule. Rule number 1 states that in front of equal angles in the triangle there are equal sides. So I will read rule number 1 again. Rule number 1 states that in front of equal angles in the triangle there are equal sides. So actually if we have a triangle ABC that has two equal angles, triangle ABC has two equal angles. That is to say, angle ABC equals to alpha, and angle BCA or angle ACB also equals to alpha. So this triangle ABC, has two equal angles. Those two angles are both equal to alpha. Therefore, according to rule number 1, in front of equal angles there are equal sides. So in front of this angle alpha we have side AB of triangle ABC, and in front of this angle alpha we have side AC of triangle ABC. So according to rule number 1, AB equals to AC. So in triangle ABC we have two equal angles. Angle ABC is equal to angle ACB. Both of those two angles are equal to angle alpha. Therefore, according to rule number 1, AB, side AB of triangle ABC equals to side AC. Because of the fact that in front of equal angles we have equal sides, that is to say, in front of this angle alpha we have side AB, and in front of this angle alpha we have side AC. And according to rule number 1, if in front of equal angles there are equal sides, so AB equals to AC according to rule number 1. Okay? So we actually can implement rule number 1 in our drawing, because in our drawing we have those two angles are equal to each other. Both of them are equal to 2x. So according to rule number 1, in front of equal angles there are equal sides. So in front of this angle 2x we have side AB, and in front of this angle 2x we have side AD, and according to rule number 1, those two sides are equal to each other. So according to rule number 1, AB equals to AD. In triangle ABD, we have two angles that are equal to each other. Angle ABD equals to angle ADB. Both those two angles are equal to 2x. Therefore, according to rule number 1, the sides that are in front of those two angles are also equal to each other. That is to say, AB equals to AD according to rule number 1. again, in triangle ABD we have two angles that are equal to each other. Angle ABD equals to angle ADB, both of them equals to angle 2x. Therefore, according to rule number 1, side AB equals to side AD. Okay? But it is given us that side AB equals to 8 units. Okay, we know that side AB equals to 8 units. So we can write down that AB equals to 8 units. And AB equals to 8 units, and from this equality we can deduce that AD also equals to 8 units. Okay, AD also equals to 8 units. So AD equals to 8 units. And we also have rule number 2, but before I explain to you, before I present rule number 2, I will explain to you what is exterior angle and what are interior angles in a triangle. So actually, if we have triangle ABC, that can be any triangle, not necessarily our triangle. This is triangle ABC. Angles alpha, beta, and gamma are defined as interior angles because they are inside triangle ABC. Okay, they are interior angles. While angle ABL, this angle is defined as exterior angle. And actually, because of the fact that angles alpha and beta are located on the opposite side of angle gamma, they are also defined in relation to angle gamma. They are defined as opposite interior angles because they are located in the opposite side of angle gamma. Okay, so angle alpha and beta are defined as opposite interior angles, and angle ABL is defined as exterior angle. Okay, so now I will present you rule number 2. Rule number 2 states that the exterior angle of a triangle, that is to say angle ABL in this example, the exterior angle in the triangle is equal to the sum of the two opposite interior angles. So I will read rule number 2 again. According to rule number 2, the exterior angle in the triangle is equal to the sum of the two opposite interior angles. So actually, if we relate to our example, rule number 2 means that angle ABL, the exterior angle ABL, is equal to the sum of the two opposite interior angles, equals to alpha plus beta, because alpha plus beta are the interior opposite exterior angles in relation to this angle. So angle ABL equals to alpha plus beta. Okay, the exterior angle ABL equals to the sum of the two opposite interior angles, that is to say, it equals to alpha plus beta. Again, the exterior angle ABL equals to the sum of the two opposite interior angles, that is to say, angle ABL equals to alpha plus beta. And again, we can implement rule number 2 in our drawing. So if we relate to triangle ADC, if we relate to triangle ADC, this triangle, in triangle ADC, we have two opposite interior angles, that are angle ADB, that are angle DAC. Again, we relate to triangle ADC. We have two opposite interior angles that are angle DAC and angle ACD. Those two angles. And the exterior angle of triangle ADC is actually this angle, angle ADB, and angle ADB is the exterior angle of triangle ADC. So I will read again the things that I wrote. In triangle ADC, we have two opposite interior angles that are angle ADC and angle ACD. Those two angles are defined as opposite interior angles, and the angle ADB is the exterior and angle ADB is the exterior angle of triangle ADC. Angle ADB is the exterior angle of triangle ADC that is actually equals to 2x. Okay, so according to rule number 2, angle DAC plus angle ACD is equal to angle ADB, this angle that actually equals to 2x. Again, according to rule number 2, angle DAC plus angle ACD equals to 2x. The sum of those two angles is equal to 2x, the exterior angle 2x. But we know that angle ACD equals 2x. So we can substitute angle ACD by x, and we will get that angle DAC plus x equals to 2x. Angle DAC plus x equals to 2x. Here we can subtract x from this equality and we get that the value of angle DAC is actually 2x minus x is x. Okay, so we found out that angle DAC equals to x degrees in size. This angle equals to x So in triangle ADC we have two equal angles. Those two angles are equal to each other in triangle ADC, this triangle. Therefore, according to rules number 1, in front of equal angles we have equal sides. There are equal sides, so actually in front of this angle alpha we have side DC of triangle ADC, and in front of this angle alpha we have side AD of triangle ADC. So according to rule number 1, AD equals to DC. Okay. Okay, so AD equals to DC according to rule number 1. Again, according to rule number 1, AD equals to DC because in front of equal angles there are equal sides. Okay, but we know that AD equals to 8 units. AD equals to 8 units. Here AD equals to 8 units. So from this equality we can deduce that DC also equals to 8 units. Okay, DC equals to 8 units. Okay, DC AD equals to DC, so DC also equals to 8 units. Okay, so in the next step I present to you rule number 3. Rule number 3 relates to an isosceles triangle. Actually, in the drawing we have two isosceles triangles, and we will relate to the isosceles triangle, triangle ABD. Triangle ABD is an isosceles triangle because of the fact that side AB equals to side AD. Both of those two sides are equal to 8 units. Okay, so rule number 1 states, rule number 3 states that the height to the base in an isosceles triangle divides the base to two equal parts. So I will read rule number 3 again. Rule number 3 states that the height to the base in an isosceles triangle divides the base to two equal parts. So actually, if we have a triangle ABC that is an isosceles triangle, so if this triangle ABC is an isosceles triangle, that is to say AB equals to AC, and we will draw a height from point A to the base BC. First of all, I will remind you that BC is the base of triangle ABC. So if we, from point A we will draw height to the base BC, the height always creates 90 degrees with the base, so actually this angle is a right angle and this angle is also a right angle, and we will define the touching point between the height to the base BC as point D. Again, point D is the touching point between the height and side BC of triangle ABC. So according to rule number 3, the height to the base, that is actually line segment AD, divides the base BC to two equal parts. That is to say, BD equals to DC. So I will repeat again. If we have an isosceles triangle, that is to say AB equals to AC, and we draw height to the base from point A, then that height will divide the base to two equal parts, that is to say BD equals to DC. Okay, so those two sides, those two line segments are equal to each other. Okay, BD equals to DC. Okay, and because of the fact that triangle ABC is an isosceles triangle, we know also that AB equals to AC. Okay, so actually we can implement rule number 3 in our drawing. Because we actually have triangle ABD that is isosceles triangle, because of the fact that side AB of triangle ABD equals to side AD, both of those sides are equal to 8 units. So in triangle the isosceles triangle ABD. AB equals to AD. For that reason, triangle ABD is an isosceles triangle. Side AB of triangle ABD equals to side AD. Both of those sides are equal to 8 units. Okay, so triangle ABD is an isosceles triangle because of the fact that side AB equals to side AD. Both of those two sides are equal to 8 units. So according to rule number 3, if we will draw height from point A to the base BD, then the height will divide the side BD to 2 equal parts. So if we draw height from point A to the base BD, that is to say the height always creates 90 degrees with the base BD, that is to say this angle is a right angle and this angle is also a right angle, and we will define the touching point between the height to the side BD is point E. Then according to rule number 3, BE equals to ED. Okay, BE equals to ED. According to rule number 3. Okay, according to rule number 3, BE equals to ED because of the fact that the height divides the base to 2 equal parts. So this part equals to this part, that is to say BE equals to ED. And if we will define BE as A, that is to say BE equals to A, then from this equality we can deduce that DE or ED also equals to A. Okay, ED also equals to A. Okay, ED also equals to A, so BE equals to A units and ED also equals to A units. Okay, actually we have here right triangle. Actually we have two right triangles because of the fact that in triangle ABE, angle AEB equals to 90 degrees. Therefore, triangle ABE is a right triangle because it has one angle that equals to 90 degrees. So I write down that triangle ABE is a right triangle because it has one angle that equals to 90 degrees. Therefore, we can implement the Pythagorean theorem in the right triangle ABE. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in triangle ABE is AB, so AB square equals to the sum of the squares of the perpendiculars equals to BE square plus AE square. We will define AE as H, that is to say AE equals to H. So equation number 1 relates to the right triangle ABE, and it states that AB square equals to BE square plus AE square. Okay? But what is the value of AB? AB equals to 8 units. It is given us in the question. So AB square is actually 8 square, and 8 square equals to 64 equals to BE. BE equals to A according to our definition. So BE square is A square plus AE square. Again, AE equals to H according to our definition. So AE square equals to H square. Okay. So in total we got the equality equation number 1 that states that 64 equals to A square plus H square. Here we'll subtract A square from this equation number 1, and we'll get that H square equals to 64 minus A square. Okay, so we got the value of H square according to equation number 1. H square equals to 64 minus A square. Okay, so in the next step we will relate to triangle AEC. Actually, triangle AEC is a right triangle because of the fact that it has one angle that equals 90 degrees. This angle equals 90 degrees, therefore triangle AEC is a right triangle. Okay, so in the right triangle AEC, we can implement the Pythagoras theorem. It states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. AC is the hypotenuse of triangle AEC. So equation number 2 will be AC square equals to the sum of the squares of the perpendiculars equals to AE square plus EC square. Again, according to the Pythagoras theorem, in the right triangle AEC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC square equals to AE square plus EC square. Okay? But what is the value of AC? AC equals to 14 units, according to what is given us in the question. So 14 AC square is 14 square, and 14 square is 196, equals to AE square. AE equals to h according to our definition, so AE square is h square plus EC square. EC square. What is the value of AC? What is the value of EC? The value of EC is actually A plus 8. So EC square will be A plus 8 square. Okay, so in total we got that 196 equals to A square plus A plus 8 square. Okay. But we have already found out in equation number 1 that h square equals to 64 minus a square. Okay, so we can substitute h square in equation number 2 by 64 minus a square. Okay, so we will do it now. We will get that 196 equals to 64 minus a square. -a square. We substituted a square by the expression that is equals to a square, to h square according to equation number 1. H square equals to 64 minus a square plus a plus h square. A plus h square equals to a square plus 64 plus 16a. Okay, a square plus 64 plus 16a. So in total we got that 196 equals to 64 minus a square plus a square. Minus a square plus a square is 0, so a square is cancelled. And we have also plus 64 plus 16a. Okay, so actually 64 plus 64 is 128. So I write it down. Again, 64 plus 64 is 128 plus 16a. So in total we got that 196 equals to 128 plus 16a. So here we will subtract 128 from this equation number 1, and we will get that 68 68, yes, 196 minus 128 is 68 equals to 16a. So here we will divide this equality equation number 2 by 16 in order to get the value of a. So according to equation number 2, A equals to 68 over 16. Okay, A equals to 68 over 16. So here we can divide the numerator and the denominator by 4, and we will get that 68 over 4 is 17, 16 over 4 is 4. So in total we got that A equals to 17 over 4 units. Okay, A equals to 17 over 4 units. That is the value of A. But we know that from question number 1, that h squared equals to 64 minus a squared. Okay, from question number 1 we know that h squared equals to 64 minus a squared, and we found out that a equals to 17 over 4 units. A equals to 17 over 4 units. So actually, if we square this equality, we will get that a squared equals to 17 squared is 289 over 4 squared is 16. So a squared equals to 289 over 16. Okay, so you can write down that h squared equals to 64 minus a squared, and we found out that a squared equals to 289 over 16, so h squared equals to 64 minus 289 over 16. So here we will multiply 64 by 16, and then we will divide it by 16 in order to have a common factor with this number. So we multiply 64 by 16 and then we divided it by 16, so we change nothing, so it is allowable. We get that h squared equals to 64 times 16 is 1024 over 16 minus 289. So h squared equals to 1024 minus 289, that is 735. Again, edge square equals to 735 over 16 300 edge square equals to 735 over 16. Here we will take a root out of this equality in order to find out the value of h. So h will be equal to the root of 735 over 16 and 735 equals to 15 times 7 times 7 and 16 equals to 4 times 4. So in total we got that h equals to 15 times 7 times 7 over 4 times 4. The root of 7 times 7 is 7 and the root of 4 times 4 is 4. So we can take 7 and 4 out of this root and we'll get that h equals to 7 over 4 and in the root what is left is root 15. Again we got h equals to 7 over 4 times root 15 units, and we also found out that these units, we also found out that a equals to 17 over 4 units. Okay, we found out the values of h and a. Now, what is the area of triangle ABC? Actually, the formula for the area of any triangle is the base of the triangle times the height to the base over 2. Okay, so actually that is the formula for the area of any triangle. The area of any triangle equals to the base times the height to the base over 2, and you must remember that the height to the base must create 90 degrees with the base. Okay, so what is the area of our triangle ABC? The area of our triangle ABC equals to the base of the triangle. The base of this triangle is BC times the height to the base. The height is AE, that equals to H. Again, the height must create 90 degrees with the base. So indeed the height that is H creates 90 degrees with the base EC. Therefore the height is indeed H. So the height of triangle ABC, the area of triangle ABC equals to the base of the triangle times the height to the base over 2. Okay, you should remember that we have already found out the value of age. Age equals to 7 over 4 times root 15. Okay, so we can substitute age by 7 over 4 times root 15, and we will get that the area of triangle ABC equals to B. First of all, I will substitute age by its value. That is actually 7 over 4 times root 15. Over 2. Okay, so the area of triangle ABC equals to the base BC times the height, that is 7 over 4 times root 15, all divided by 2. But what is the value of BC? The value of BC equals to A plus 8. Again, the size of BC is A plus 8. So in total, the BC equals to 2 times A plus 8. Here we have 7 over 4 times root 15 over 2. So that is the area of triangle ABC. Okay, the area of triangle ABC equals to 2 times A plus 8 times 7 over 4 times root 15 over 2. But we have already found out that A equals to 17 over 4 units. So here we have 2 times A, 2 times 17 over 4 is 17 over 2. So I write it down. So we will get that the area of triangle ABC equals to 17 over 2, that is 2A, plus 8 times 7 over 4 times root 15 over 2. Okay, we got the area of triangle ABC. It equals to 17 over 2 plus 8 times 7 over 4 times root 15 over 2. So here we have 17 over 2 plus 8. So instead of 8, I will write 16 over 2, that is equals to 8, in order to get the common factor in the denominator, that is 2. Okay, so the area of triangle ABC equals to 17 over 2 plus 16 over 2 times 7 times root 15, and we can move the 2 to the denominator. We will get that 2 times 4 is 8. Okay, in total we got that the area of triangle ABC equals to 17 plus 16 times 7 times root 15. In the denominator we have 2 times 8. 2 times 8 is 16. And 17 plus 16 is 33. So I will write it down. The area of triangle ABC will be equal to 33 times 7 times root 15 over 2 times 8 is 16. So in total we got that the area of triangle ABC equals to 33 times 7 is 231 times root 15 over 16. So the final answer to the question is that the area of triangle ABC equals to 33 times 7 is 231 times root 15 over 16. Okay, so we got the area of triangle ABC. We found out that the area of triangle ABC equals to 231 times root 15 over 16 square units. Okay, so in the next step I will present to you a second way to find out the area of triangle ABC. So first of all we will find the size of angle A, this angle. We know that the sum of the angles in any triangle equals to 180 degrees. So the sum of the angles in this triangle also must be equal to 180 degrees. So angle A plus angle B plus angle C equals to 180 degrees. Okay, again this equality states that the sum of the three angles inside triangle ABC must be equal to 180 degrees. It is true for any triangle in the world, the sum of its angles equals to 180 degrees. Okay, angle A plus angle B plus angle C must be equal to 180 degrees. So angle A plus angle B, what is the size of angle B? Angle B equals to 2x. And what is the size of angle C? Angle C equals to x. So in total we got that angle A plus 2x plus x equals to 180 degrees. 2x plus x equals to 3x. So I will write it down. Angle A plus 3x must be equal to 180 degrees. So here I will subtract 3x from this equality in order to get the value of A. So we will get that the side of angle A equals to 180 degrees minus 3x. So we found out the size of angle A. The size of angle A equals to 180 degrees minus 3x. So we can write down that the size of angle A equals to 180 degrees minus 3x. Again, the size of angle A equals to 100 degrees minus 3x degrees. So after we found out the value of angle A, I will present to you a new rule, rule number 4, that is actually a new formula that calculates the area of any triangle. Okay, so rule number 4 states the formula for the area of any triangle. Rule number 4. So if we have triangle ABC, so if we have triangle ABC, that can be any triangle, not necessarily our triangle ABC, but any other triangle. And we know that the size of side AB of triangle ABC equals to A units, and the size of side AC of triangle ABC equals to B units. And we also know that the angle between side AB and side AC of triangle ABC equals to theta. Then, according to rule number 4, the area of triangle ABC is equal to A times B times sine theta over 2. Okay, we can use this formula in any triangle. The area of any triangle is equal to A times B times sine theta over 2. Okay, so actually we can implement rule number 4 in our triangle ABC, and we will calculate the area of our triangle ABC according to rule number 4. So actually, according to rule number 4, the area, I will use the capital letter A for the area. A is abbreviation for area. So the area of our triangle ABC will be equal to AB times AC times sine of 180 degrees minus 3x over 2. Okay, so the area of our triangle ABC according to rule number 4 equals to AB times AC times sine of 180 degrees minus 3x over 2. Okay, but what is the value of AB? AB equals to 8 units. It is given us in the question. So the area of triangle ABC will be equal to 8 times AC. What is the value of AC? AC equals to 14 units according to what is given us in the question, times sine of 180 degrees minus 3x over 2. So we found out that the area of our triangle ABC equals to 8 times 14 times sine of 180 degrees minus 3x over 2. Here 14 over 2 is 7, and 7 times 8 is 56. So I write it down. So the area of triangle ABC equals to 56 times sine of 180 degrees minus 3x. So equation number 1 states that the area of triangle ABC equals to 56 times sine of 180 degrees minus 3x. I will present to you a trigonometric identity, and we will use it in this formula. The trigonometric identity states that sine of 180 degrees minus alpha equals to sine alpha. Again, the trigonometric identity states that sine of 180 degrees minus alpha equals to sine alpha. So here we can use this trigonometric identity, and sine of 180 degrees minus 3x will be equal to sine 3x according to this trigonometric identity. So we will get that the area of triangle ABC equals to 56 times sine of 3x. Okay, again, sine of 180 degrees minus 3x equals to sine 3x according to this trigonometric identity. So equation number 1 states that the area of triangle ABC equals to 56 times sine 3x. Okay, so in the next step I will present you a new rule, rule number 5, that is actually the law of sines. Okay, rule number 5 is the law of sines. Okay, the law of sines. I must emphasize that the law of sines is valid in any triangle. Okay, so first of all I write down that in any triangle you can use the law of sines in any triangle. So actually, if we have triangle ABC, it can be any triangle, not necessarily our triangle ABC, but any other triangle. And the size of side BC of triangle ABC is A units. The size of AB, side AB of triangle ABC is C units. And the size of side AC of triangle ABC equals to B units. Okay. And also we know that capital A is the size of this angle, capital B is the size of this angle, and capital C is the size of this angle. Then according to the law of sines, A over sinus A, again A sinus A is the size of this angle, so A over sinus A equals to B over sinus B over sinus B equals to C over sin C. Again, the law of sines states that A over sinus A equals to B over sinus B equals to C over sinus C, when capital A, capital B, and capital C are the sizes of angles, this angle, and this angle. Okay? A over sinus A equals to B over sinus B equals to C over sin C. So we actually can implement the law of sines in our triangle ABC. So according to the law of sines, according to the law of sines. Now triangle ABC, AB over sine x equals to AC over sine 2x. Okay, AB over sine x equals to AC over sine 2x. Okay, according to the law of sines, AB over sine x equals to AC over sine 2x. But what is the value of AB? AB equals to 8 units. It is given us in the question. So 8 over sine x equals to AC. What is AC? The value of AC is 14 units. It is also given us in the question. It is 14 over sine 2x. So in total we got that 8 over sine x equals to 14 over sine 2x. And we have the trigonometric identity for sine 2x. According to the following trigonometric identity, the value of sine 2x is actually equals to 2 sine x cosine x. Okay. According to this trigonometric identity, the value of sine 2x equals to 2 sine x cosine x. So we can substitute sine 2x in this equality by 2 sine x cosinus x. Okay, so we'll do it now. And we will get that 8 over sine x equals to 14 over sine 2x, and sine 2x equals to 2 sine x cosinus cosine x according to this trigonometric identity. Okay, we got that 8 over sine x equals to 14 over 2 sine x cosine x. Here in this equality we have sine x in the denominator of this side of the equation, and we have sine x in the denominator of the other side of the equation, so we can cancel sine x because we have sine x in both sides of the equation. Okay, and we also know that 14 over 2 is 7, so I'll write it down that 7 over cosine x equals to 8. So in total we got that 7 over cosine x equals to 8. Here we will multiply this equality by cosine x, and then we will divide it by 8. We will get that cosine x equals to 7 over 8. So we found out that the value of cosine x equals to 7 over 8. In the next step, I will present to you a trigonometric identity, and from that trigonometric identity we will find out the value of sine x. The trigonometric identity states that sine square x plus cosine square x equals to 1. Okay, from this trigonometric identity we will find out the value of sine x. Here we will subtract from this trigonometric identity cosine square x, and we will get that sine square x equals to 1 minus cosine square x. Okay, so here we'll take a root out of this equality in order to find out the value of sine x. We will get that sine x equals to the root of 1 minus cosine square x. Okay, so we actually found out the value of sine x. Sine x equals to the root of 1 minus cosine square x. Okay, but we know that the value of cosine x equals to 7 over 8. So if we will square this equality, we will get the value of cosine x in order to substitute it by cosine x in this equality. Okay, so we will square this equality. Cosine x cosine square x will be equal to 7 square is 49 over 8 square is 64. So we found out the value of cosine square x, and now we can substitute cosine square x in this equality by 49 over 64, because cosine square x equals to 49 over 64. So we will get that the value of sine x is actually, it equals to the root of 1 minus cosine square x equals to 49 over 64. Okay, so in total we got that sine x equals to the root of 1 minus 49 over 64. Here we will write that instead of 1 we will write 64 over 64, that equals to 1, in order to have a common factor with this number. Okay, so we'll get that the value of sine x equals to the root of 64 over 64, 64 minus 49 over 64. Okay, so sine x equals to the root of 64 minus 49 is 15, and the root of 64 is 8, so 8 will be out of this root. In total we got that sine x equals to root 15 over 8. So now we will return to our first equation, that is the calculation of the area of triangle ABC. That is actually the question of this lecture, to find out the area of triangle ABC. So we found out that the area of triangle ABC, according to equation number 1, area A is abbreviation for area, so the area of triangle ABC equals to 56 times sine of 3x. Okay, that is actually what we have already found out, that the area of triangle ABC equals to 56 times sine of 3x. Okay, so we must find the value of sine x. Actually, we have new trigonometric identity for sine 3x. According to that trigonometric identity, the value of sine 3x equals to 3 sine x minus 4 sine cube x. Okay, so we will use this trigonometric identity in our equation number 1. According to this trigonometric identity, sine of 3x equals to 3 sine x minus 4 sine cube x. Okay, so we will substitute sine 3x by this expression, because sine 3x equals to this expression, and we will get that the area of triangle ABC equals to 56 times, instead of sine 3x, we will use the trigonometric identity for sine 3x. Sine 3x actually equals to 3 sine x minus 4 sine cube x. Okay, so we found out that the area of triangle ABC equals to 56 times 3 sine x minus 4 sine cube x. Here we will take sine x as a common factor of this expression. We will take out sine x as a common factor of this expression, and we will get that the area of triangle ABC equals to 56 times sine x. We took sine x as a common factor of this expression, sine x, and inside the brackets what is left is, here after we took out sine x as a common factor of this expression, what is left is, here is 3 minus 4 sine square x. So in total we got that the value, or the area of triangle ABC, equals to 56 times sine x. In the brackets we have 3 minus 4 sine square x. But we have already found out that the value of sine x is actually root 15 over 8. Okay, the value of sine x is root 15 over 8 the value of sine x is root 15 over 8 sine x equals to root 15 over 8 now we will square this equality in order to get the value of sine square x. So sine square x equals to 15, root 15 times root 15 is 15, over 8 square is 64. So the value of sine square x equals to 15 over 64. So now the only thing that is left to do is to substitute sine x by root 15 over 8 and to substitute sine square x by 15 over 64, and we will find out the area of triangle ABC. Okay, so we will get that the area of triangle ABC equals to 56 sine x. We will substitute sine x equals to root 15 over 8 times 3 minus 4 times sine square x equals to 15 over 64. So in total we found out that the area of triangle ABC equals to 56 times root 15 over 8, and in the brackets we have 3 minus 4 times 15 over 64. First of all, 56 over 8 is 7, and here we have 4 in the numerator, so we will divide this expression by 4, and 64 over 4 is 16. So in total, the area of triangle ABC equals to 7 times root 15. In the brackets we have 3 minus, so here we have 15 over 16 because we cancelled 4. We divided the numerator and the denominator by 4. So what is left is 15 over 16. So in total, the area of triangle ABC equals to 7 times root 15. In the brackets we have 3 minus 15 over 16. So here we will substitute 3 by 48 over 16 in order to have a common factor with this number. Okay, we will get that the area of triangle ABC equals to root 15 times 7. Instead of 3, we will write down 48 over 16 that equals to 3, so we will change nothing, minus 15. So in total we got that the area of triangle ABC equals to root 15 times 7, and in the brackets we have 48 minus 15, that is 33. So I'll write it down. The area of triangle ABC equals to root 15 times 7. 48 minus 15 is 33 over 16. Okay, the area of triangle ABC equals to root 15 times 7 times 33 is 231 over 16. So the final answer is that the area of triangle ABC equals to root 15 times 231. 33 times 7 is 231 over 16 square units. Again, the area of triangle ABC equals to root 15 times 231 over 16 square units. Now we will check if we got the same answer in the first method. In the first method, we got that the area of triangle ABC equals to (231) times root 15 over 16 square units. That is exactly what we got in the second method. So now I will summarize the lecture. Actually, we wanted to find out the area of triangle ABC. We know that side AB of triangle ABC equals to 8 units, side AC equals to 14 units, angle ABC equals to 2x, and angle ACB equals to x degrees in size, and we want to find out the area of triangle ABC. And actually the first thing that we did is a construction. Actually we built line segment AD in such a way that the angle that was created with side BC is 2x, that equals to this angle, and in this way we created triangle ADB that has two equal angles. And then we used the rule number 1 that states that in front of equal angles there are equal sides, and we know that side AB equals to 8 units, so according to equation number 1, side AD also must be equal to 8 units. Okay. So actually, as I've already told you, we built line segment AD in such a way that this angle ADB will be equal to 2x, exactly like this angle. And in this way we created two equal angles in triangle ADB, and we have rule number one that states that in front of equal angles there are equal sides. So if you have a triangle ABC that has two equal angles, that is to say those two angles are equal to each other, both of them equals to alpha, then in front of equal angles we have equal sides, that is to say AB equals to AC. So we can implement rule number one in triangle ABD that has two equal angles. Therefore, according to rule number one, AB equals to AD. Again, in triangle ABD, AB equals to AD according to rule number one, but we know that AB equals to 8 units. AB equals to 8 units, so from this equality we can deduce that AD also equals to 8 units, okay? So the size of AD is also equals to 8 units. And then I presented to you rule number two that states that if we have I explained to you what is external angle in triangle ABC. Angle ABL is external angle, and angles alpha and beta are defined as opposite interior angles. And according to rule number two, the exterior angle in the triangle is equal to the sum of the two opposite interior angles. Okay, the exterior angle in the triangle is equal to the sum of the two opposite interior angles, that is to say angle ABL equals to alpha plus beta. This exterior angle ABL equals to the sum of the two opposite interior angles, that is to say angle ABL equals to alpha plus beta. So we can implement rule number two in our triangle, in our drawing. We actually have triangle ADC, this triangle ADC that has two opposite interior angles, and we have this external angle that equals to 2x. So according to rule number one, this external angle that equals to 2x will also be equal to the sum of those two angles, or in other words, the external angle 2x equals to the sum of the two interior opposite angles, or 2x equals to angle DAC plus angle ACD, and this angle 2x equals to the sum of those two angles. But we know that angle ACD equals to x, this angle equals to x, so here we subtracted x from this equality and we got that angle DAC also equals to x, so this angle also equals to x. So here we have triangle ADC that has two equal angles, and according to rule number 1, in front of equal angles there are equal sides. That is to say, AD equals to DC. But we know that AD equals to 8 units, so DC also must be equal to 8 units. Okay, then I presented to you rule number 3 that states that the height to the base in an isosceles triangle divides the base to two equal parts. Okay, rule number 3 states that the height to the base in an isosceles triangle divides the base to two equal parts. The meaning of rule number 3 is that if you have triangle ABC that is an isosceles triangle, that is to say AB equals to AC, then if you draw height from point A to the base BC, then that height divides the base BC to two equal parts, that is to say BD equals to AC. Okay, so we can implement rule number 3 in our drawing, because we have here an isosceles triangle, because triangle ABD is an isosceles triangle because AB equals to AD. So if we draw height to the base BD, then that height will divide the base BD to two equal parts, that is to say BE equals to ED. Okay, then we define BE as A, that is to say BE equals to A, and because of the fact that BE equals to ED, ED also will be equal to A. Okay, and so the height creates 90 degrees of the base. Okay, so this angle is 90 degrees and this angle is also 90 degrees. So we have this angle that equals to 90 degrees. That is to say, in triangle ABE we have one angle that equals to 90 degrees. Therefore, triangle ABE is a right triangle. Therefore, we can implement the Pythagorean theorem in the right triangle ABE. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square equals to EB square plus AE square. Okay, but we know that AB equals to 8 units, so AB square is 8 square and 8 square is 64 equals to BE square. BE equals to A according to our definition, so BE square will be equal to A square, and AE equals to H according to our definition, so AE square will be equal to H square. So from this equation number 1 we got that H square equals to 64 minus A square. And then we created equation number 2 that states that actually triangle AEC is a right triangle because it has one angle that equals to 90 degrees. This angle AEC equals to 90 degrees. Therefore, triangle AEC is a right triangle. Therefore, we can implement the Pythagorean theorem in the right triangle AEC. According to the Pythagorean theorem, the square of the hypotenuse, that is AC square, equals to the sum of the squares of the perpendiculars, equals to AE square plus EC square. Okay, according to the Pythagorean theorem, in the right triangle AEC, AC square equals to AE square plus EC square. But we know that AC equals to 14 units, so AC square is 14 square is 196. AE equals to H, so AE square is H square. And what is the value of EC? EC EC equals to A plus 8. So EC squared is A plus 8 squared. So after we solve the, actually we have here 8 squared, and from equation number 1, we can, we know from equation number 1 that 8 squared equals to 64 minus 8 squared. So we can substitute 8 squared in equation number 2 by 64 minus 8 squared, because 8 squared equals to 64 minus 8 squared. So we got here only one variable that is missing, that is A, and we solved this equation and we found out that A equals to 17 over 4 units. After we found out that A equals to 17 over 4 units, we found the value of H. In equation number 1, we have H squared equals to 64 minus A squared. And we have already found out that A equals to 17 over 4 units, so A squared will be equal to 289 over 16. So we can substitute A squared by 289 over 16. So we did it, and we found out that the value of H is actually H equals to H equals to 7 over 4 times root 15 units, and we have already found out that A equals to 17 over 4 units. Okay, so after we found out the value of H and A, it is very easy to find out the area of triangle ABC, because the area of any triangle equals to the base of the triangle times the height to the base over 2. So the area of triangle ABC will be equal to the base of the triangle, that is BC, times the height to the base, that is H, over 2. Okay, the area of triangle ABC equals to the base BC times the height to the base, that is H, over 2. You should remember that the height must create 90 degrees with the base, and indeed H creates 90 degrees with the base. Therefore, H is the height of triangle ABC. And we have already found out that the value of H is 7 over 4 times root 15. And the value of A is 17 over 4 units. So the only thing that is left is to put the data inside the equality and to find out the area of triangle ABC. And we found out that the area of triangle ABC equals to 231 times root 15 over 16 square units. Okay, then I presented you a second way to find out the area of triangle ABC. First of all, we found out the size of angle A. We know that the sum of the angles in any triangle equals to 180 degrees. That is to say, angle A plus angle B plus angle C must be equal to 180 degrees. And we found the value of angle A by the statement that angle A plus angle B plus angle C must be equal to 180 degrees. And we know that angle B equals to 2x and angle C equals to x. Okay, we substituted B by 2x and C by x. We got that the value of angle A equals to 180 degrees minus 3x. Okay, angle A equals to 180 degrees minus 3x. Then I presented to you a new rule number 4. That is actually a new formula to find out the area of any triangle. According to rule number 4, the area of any triangle can be calculated according to the following formula that states that the area of any triangle equals to A times B times sinus theta over 2. And we calculated the area of our triangle ABC, according to rule number 4. So the area of our triangle ABC equals to AB times AC times sinus 180 degrees minus 3x over 2. Okay? The area of triangle ABC equals to AB times AC times sinus 180 degrees minus 3x over 2. We know that AB equals to 8 units, AC equals to 14 units. Okay? So we got that the area of triangle ABC equals to 56 times sine of 180 degrees minus 3x. And we have the trigonometric identity that states that the area, that sine of 130 degrees minus alpha equals to sine alpha. So according to this trigonometric identity, sine of 180 degrees minus 3x equals to sine 3x. So we got that the area of triangle ABC equals to 56 sine 3x. Okay, and then I presented to you rule number 5, that is actually the law of sines. According to the law of sines, in any triangle, A over sinus A equals to B over sinus B equals to C over sinus C. Okay? A over sinus A equals to B over sinus B equals to C over sinus C. Again, we can implement the law of sines in our triangle ABC. According to the law of sines, in our triangle ABC, AB over sine x will be equal to AC over sine 2x. Okay, AB over sine x equals to AC over sine 2x. We know that AB equals to 8 units and AC equals to 14 units. Okay, AB equals to 8 units and AC equals to 14 units. And we have the trigonometric identity that states that sine 2x equals to 2 sine x cosinus x. So we can substitute sine 2x by this expression, and we got that the value of cosine x, according to the formula that we had, that cosine x equals to 7 over 8. Then I presented to you a trigonometric identity that sine square x plus cosine square x equals to 1, and from this trigonometric identity we got the value of sine x. We got here that sine x equals to the root of 1 minus cosine square x, and we know that cosine x equals to 7 over 8, and we squared this equality, and we found out that cosine square x equals to 49 over 64. And then we substituted cosine square x by 49 over 64, and we found out that the value of sine x equals to root 15 over 8. And we have the equation number 1 that states that the area of triangle ABC equals to 56 sine 3x. So here I presented to you the trigonometric identity for sine 3x. According to the trigonometric identity, sine 3x equals to 3 sine x minus 4 sine cube x. Okay, so we substituted sine 3x by this identity because it equals to sine 3x, and we got the equality that states that the area of triangle ABC equals to 56 times sine x. In the brackets we have 3 minus 4 sine square x, and we know that sine x equals to root 15 over 8. So we squared this equality and we got that sine square x equals to 15 over 64. So the only thing that is left to do is to substitute sine x by root 15 over 8 and to substitute sine square x by 15 over 64. So we did it and we found out that the area of triangle ABC equals to root 15 times 231 over 16 square units. Again, the area of this triangle ABC equals to root 15 times 231 over 16 square units. Okay, thank you very much.